Hello everyone. Today we are again here with the new subtopic of the topic what we have discussed in our previous lecture. So today we are going to discuss about irrational number. Irrational number is a part of a real number chapter which is also having a very much importance as one question from this chapter has come most frequently, which is about how to prove a number is irrational number. What is irrational number? A number which cannot be expressed in the form of p by q, where q is not equal to 0 and p and q are integers, is known as irrational number. Now what we are going to learn here is we are going to see that how we can prove a number is irrational number. So before we start with that, one important theorem about which we need to know is here, that is, let p be a prime, and if p divides a square, then p divides a also, where a is a positive integer. So how we are going to prove it? So if we'll talk about the proof, so you know that as per the fundamental theorem of arithmetic, every composite number can be expressed as the product of prime. So if a is a positive number, we can write a equals to p1 into p2 into p3 and so on up to pn, where p1, p2, p3, etc. up to pn are primes. And then when you square it, if suppose I will square both sides here, so what will happen? A square will be equals to p1 into p2 into p3 and so on up to pn whole square. And by laws of exponent, we can write it as p1 square into p2 square into p3 square and so on up to pn square. Now what we see here is, see, even if you square, our prime factors does not change. That means whatever was the prime factor of a, still the same prime factors are there for a square also. So what we can say here, p1, p2, p3 and so on pn are prime factors of a square, which is also the factors of a. And so therefore we can say that since if any p of the a square divides a square, that means it will divide a also. So we can say since p divides a square, that implies p divides a also, where p is one of p1, p2, p3 and so on up to pn. So this is how we can prove the theorem, and this is very important one because in almost all the questions we are going to use the statement in order to prove it. So now let's move towards the questions. So the first type of question is prove that root 5 is an irrational number. Now see here what it can be. In place of 5 it can be any other prime number, will follow the same set of patterns. whether it is root 5, root 2, root 3, or I can say root 7, root 11, root 13, we are going to follow the same pattern or the same steps which will solve to prove root 5 is irrational number. So what we are going to do here, we are going to prove it by the method of contradiction. So what we'll do here, as in the question they have given prove that root 5 is an irrational number, we'll take it to be the rational number. And then with some set of steps, we will prove that what we have assumed that is wrong, and if what we have assumed is wrong, that means what is given in the question that is right, because we know a real number will be either rational or irrational. So if it will not be rational, definitely it will be an irrational number. So let's start the proof. So in order to prove that, we'll take first, let root 5 be a rational number. And since root 5 is a rational number, we know every rational number can be written in the form of p by q, where p and q are integers and q is not equal to 0. And in that case, it may be possible that p and q may have some common factor. So what we are going to do here, we are going to write a by b rather than p by q, and there we will take a and b as co-prime number. Remember, co-prime numbers are those numbers which have only one as the common factor. So since root 5 is a rational number, we can write therefore root 5 equals to a upon b. Then when you cross multiply, you will get a equals to root 5 times b. Now if you square both sides, we'll get a square equals to root 5b whole square. Now that means a square equal to 5b square. We can write using laws of exponent. Now this is the statement where we'll use the theorem what we have just learned some time back. Now here what we can observe, that since 5 is a factor of a square, which is also a prime, which implies 5 is a factor of a. And since 5 is a factor of a, that means a is a multiple of 5. So now let a equals to 5m, where m belongs to some integer. And now what we'll do, we'll square it. Squaring both sides, what we'll get, a square equals to 5m whole square, which will be equals to a square equals to 25 m square. Now we'll substitute the value of a square from equation 1. So it will be 5b square equals to 25 m square. 5 will cancel 25. We'll get b square equal to 5m square. Now again, we can see here that 5 is a prime factor of b square. So we'll say since 5 divides b square, therefore 5 divides b. And from this now we have reached to a statement where we are contradicting our own initial assumption. As we had said in this case, one more thing, that a, b are co-prime. So as we have said in the beginning that a and b are co-prime. So what we observe here is that therefore 5 is a common factor of a and b, which is a contradiction. Now, since this is a contradiction and it has happened because of what? It is because of our wrong assumption. So that means if it is contradicting our own statement, therefore what we can say that therefore our assumption is wrong and hence root 5 is an irrational number. So this is how we are going to solve these type of questions. Now in place of suppose if I say root 7 is irrational number. So wherever you see 5, that will get replaced by 7. Wherever we have taken 5 square, which will be 25, will be replaced by 7 square, which will be 49. Wherever we have said 5 divides a square or 5 divides b square, that statement will be changed with 7 divides a square, 7 divides b square, and so on. That way you can solve for all the prime numbers in such cases. Right? I hope it is clear. Now, let's move to the next type of question. Now here it is given, prove that 2 plus 3 root 5 is an irrational number. So when we have to prove these type of question, we have to also see that for how many marks they have asked that question, and based on that we need to go. Sometime in the exam itself they say that prove that 2 plus 3 root 5 is irrational, where root 5 is irrational. So in that case you do not need to prove that root 5 is irrational. If they have not given and it is supposed for 3 or 4 marks, then it is advisable that you prove first root 5 is irrational number, and then we'll prove that how 2 plus 3 root 5 is an irrational number. So here consider that where root 5 is irrational. If not, then we'll have to prove it irrational first, and then we'll proceed how we are going to solve it now. So if you see the proof of it, again we'll assume let 2 plus 3 root 5 be rational, and since it is rational, therefore what we can write 2 plus 3 root 5 equals to a by b. Now what we'll be doing is we'll be collecting all the rational terms to one side and all the irrational terms to other side. So it will become 3 root 5 equals to a upon b minus 2, which will be how much? This will be b a minus 2b. So that means root 5 will be a minus 2b upon 3b. Now what we see here is, here a minus 2b upon 3b is rational. As you know that a is rational, b is rational, and b is not equal to 0. So any operation you perform on two rational number, it will result in rational number only. So here a minus 2b upon 3b is rational, but root 5 is irrational. Now again it is contradictory because our LHS and RHS is not equal. So we can write which is contradictory. So this contradiction has happened. Why? Because of our wrong assumption. Therefore we can say our assumption is wrong, and hence 2 plus 3 root 5 is an irrational number. So this is how we are going to prove these type of questions. Now, the next type of question what can come is where they have given sum of two irrational terms is irrational. This is what we have to prove. So let's prove this type of question also. Now in this case, again, what happens, it depends on the marks, that for how many marks they have given. If they have given for higher marks, ensure that either root 2 or root 3 you can prove it as irrational, and then you can proceed as how we are going to do here. If they have already given that root 2 and root 3 are irrational, then you do not need to prove that part. And remember, we cannot say here that since root 2 is irrational, root 3 is irrational, so their sum is irrational. Because the sum of two irrational number may or may not be irrational. So how we are going to prove this type of question? Let's see that. So again we'll take let root 2 plus root 3 be a rational number. Then since it is a rational number, we can write it as root 2 plus root 3 equals to a by b. Now, you know that transposing the term to the other side is not going to make any difference, because already one side we have rational, one side we have irrational terms. So here we are going to square both sides. So in square both sides, it will be root 2 plus root 3 whole square equals to a upon b whole square. Now if you use a plus b whole square identity, which we all know, it will be root 2 whole square plus root 3 whole square plus 2 into root 2 into root 3 equals to a square upon b square. Root 2 square will be 2, root 3 square will be 3, and 2, you know that root of 2 into root of 3 is root 2 into 3, which will be root 6, which is a square upon b square. Now this will become 5 plus 2 root 6 equals to a square upon b square. Now if I'll transpose 5 to the right hand side, we'll get 2 root 6 equals to a square upon b square minus 5, which will be LCM is b square, it will be a square minus 5b square. Now we'll transpose the 2 also to the right hand side. So in this case, we'll get root 6 equals to a square minus 5b square upon 2b square. Now in this case, root 6 is an irrational number, right? It may be possible that they will give you into the question, but even if it is not, consider that because the root 6 is an irrational number. We don't need to prove it. So what we can say, that here, since a square minus 5b square upon 2b square is rational, but root 6 is irrational. So we can say that LHS and RHS are not equal, so which is contradictory. Therefore, our assumption is wrong, and hence root 2 plus root 3 is an irrational number. So this is how we are going to solve these type of questions. So more or less these type of questions will be coming from this subtopic, where we'll have to prove that prove a number is an irrational number. So this is all for this particular subtopic of real numbers. I hope it has been clear to you all. Thank you. Take care everyone.